Okay, Jason, over to yourself.
Thanks very much, Paul. Yeah, thanks for inviting us to do this lunch and learn this afternoon. As Paul said, my name's Jason Horrex. I work for Saint-Gobain in Ireland, looking after our technical academies in Kings Court and Kilcarby or in Dublin, offering our training sessions. And this afternoon, I've got a sort of 20-25 minute presentation on our InteWall dry lining solution. So it's something different to traditional dry lining. I've my colleague Evan O'Keefe with me this afternoon online, so he's going to monitor the chat. And then when we get to the end of the presentation, we'll try and field as many of the questions that you have as possible. So if we can get the thing to click on. So I suppose to state the obvious, with the opening slide, even sort of for dry lining, so traditional dry lining where you're bringing studs, plasterboards, insulation to site independently. We face challenges with regards to skill shortages, so in terms of experience skills, increasing costs. We have demands on us with regards to climate needs and sustainability. We witness changing demographics. And we've got demands on us with regards to future-proofing, substantiation, longevity of systems, etc., and making sure that there's a chain of evidence going through from conception through to sign off. So across the 20-minute presentation, going to highlight how InteWall, which is a system which promotes solution ownership from design through to installation, working through a digital pathway with evidence-based test evidence behind that, can provide potentially an alternative solution to traditional dry lining in the right scenario. And we will drill down into choosing the right projects that suit this particular type of solution. So just as a quick overview in terms of what InteWall is and where it differs from your traditional dry lining solutions, InteWall is a pre-panelized dry lining solution. So the diagram or the image that you see on the right-hand side of the screen is essentially the build-up with 600mm wide units, pre-framed, pre-boarded, pre-insulated, that arrive on site to be installed as a panelized system rather than, and I'm going to use this term as we go through, the sort of traditional stick build method of dry lining. It's not just the product or the system, but it's the way that we deliver the product to ultimately to be installed on the site. So working with a product configurator, and I'll go into that in more detail through the presentation, we work early engagement with the project team and the client to determine what the needs are and how they can best be met through an optimization package and a standardization package to deliver the requirements at the end of the project. Pre-panelized system or partitions are manufactured off-site, so they're assembled off-site. The products are manufactured to suit the specific size of the panels and the components, so that you're helping to manage your materials not just on site but also in behind the scenes through the manufacturing and the assembly process. Pre-panelized nature of the panels obviously is going to enhance site efficiencies. You're speeding up the nature of the build, you're reducing the level of skilled labor that's required, you're reducing the waste, and hopefully over the whole project you're reducing the level of risk to all parties through that chain. If we look at it in a little bit more detail, so what you can see in terms of the animation is wall guides going up onto the sort of the end of the run, and then the panels are interlocked together, so there's like a tongue and groove system on the panels. They sit on a floor guide and they form a twin frame system. So what's on the screen at the moment is one half of your partition system, and then ultimately you've got a second half to form a twin frame, which is typically what would be the type of construction twin frame systems being used for high performance partition walls in many types of buildings. The system's fully substantiated, so across the overall partition build-up, you have up to 120 minutes fire resistance. Specifications are available for 90 and 120 minutes fire resistance. Both systems Both those fire resistant solutions are going to give you a performance in terms of sound performance at 65 RWdB sound insulation. The RWdB does refer to laboratory tested performances. When you bring that back to site and you're looking to meet building regulation requirements, you've got a tolerance there of 12 decibels over and above the requirements needed on site. So that's a good tolerance, and it's a healthy tolerance that would typically be sort of used in traditional build as well. So that's mirroring the traditional built environment. And because you've got sort of 600 mil wide modules of framing, and you've got the interlocking system of the framing and the double boarding on the solution, you've got a severe duty partition system in terms of its robustness and its impactness. All of those are backed up, all those performances are backed up by test evidence. So you have a fully substantiated system meeting all of those performance requirements. Just to go into a little bit more detail so that you have a flavour of what the panels are. So I suppose the animation on the right hand side is the pre-panelized system. So you have, that's the unit that's being received on site. You can see from the plan diagram the sort of the male and the female end of the system, they lock into each other. And what you will have on a project is a mix of standardized panels and bespoke panels. Your standard panels are 600 mil wide. The height of the panel is supplied to span floor to ceiling, so you've got no horizontal jointing in the partition solution. You've got units that can be designed as standard units because typically the volume you've generally got lots of door heads. So you can have specific door head units which have got cloaking plasterboard so that the door reveal can be concealed to a certain extent, you know, to manage that junction from the best possible way from fire and acoustic purposes. But you've also got, you're going to have a mix of bespoke. You're always going to have end of run units. You're going to have some detailing that's going to require panels that are not quite the 600 mil wide. They can also be supplied as panels, or they can be, the project team can elect to go back to the traditional form of stick building, frame and boarding to finish off those partition runs, because it might be more efficient to do that within a mix. So it's not necessarily that InteWall is the solution for everything on site, but you're trying to get those percentages up above sort of 80% mix, certainly for a project. So in terms of identifying the type of project that is suitable for InteWall, what you're looking for, as you probably are with any sort of, you know, when we look at modern methods of construction and we look at off-site manufacture, you're looking for levels of repetition that can be applied and standardization that can be applied off-site and then brought on to the project and delivered to deliver all of those performance requirements. So typical types of buildings would be those that are multiple occupancy with repetition of specification. I've got repetition of layouts on the slide, but that doesn't mean that you have to have exactly the same layout for it, you know, for all of the separating units. But what you want is a repetition of specifications so that you've got that same specification of panel being used for a large percentage or a large area of the building. So what that lends itself, certainly with regards to projects which are regulated with regards to fire and acoustic performances. You've got residential environments, but you've also got hotels, nursing homes, student accommodation, which would be very similar, that would lend itself to the same types of project. So once you've sort of identified the sort of rough project that you're looking for, you're looking to establish an early engagement with the project team to establish whether this is the right project to use InteWall on. So this is where we bring the product configurator in. So it's a software tool, and we've partnered with a company called Cope, and it's specifically developed for the InteWall system. It's been developed over the last 2.5 years. So there's been iterations and developments within that software to improve and make it more specific, as we've done pilot projects and projects within the UK and one project in Ireland to deliver InteWall onto site. So throughout that design project, so you're basically taking your BIM files. So the project that does need to be, you know, it does rely on this digital pathway. So you're putting your BIM files into the Cope product configurator. You're analyzing what you need within that, and there are 3 levels of sort of pass or appraisal that we'll go through, and I'll highlight those in a moment. And that then is going to essentially deliver your sort of BOM. So you're sort of going from BIM to BOM through the COPE product configurator in terms of the approach here. It's very much a collaborative approach. As I said, that the COPE software has been developed and is advancing all the time and being more specific to the challenges that we see in certain scenarios around doors, around junctions, around tolerances, and those variables are being built into the product configurator so that we can optimize and analyze the requirements as best as possible, so deliver, and we don't get any surprises at the end of the project, and you deliver your schedules, etc. So in terms of those three stages of design, so the first pass, once you've sort of identified the type of project that you're looking maybe to present InteWall on, you put your first pass using your BIM files into COPE. And what you'll get is you'll get a sort of an overarching appraisal which will identify the level of standardization. So in this example here, from this just a sort of random example that I'm highlighting here, that we can see that overall there's 13,500 panels, 10,500 panels will be primary panels or standard panels, and the other just over 3,000 would be bespoke units. So that's 76% in terms of the actual panel requirements, but because generally your bespoke units are smaller than the 600 mil wide, when you start to look at it in terms of area, then you can see that you're in excess of 80%, nearly touching 90% in this example of standardization on that project. At this point, you're starting to go, well, yes, this project's suitable. Once we get above that sort of 80% threshold and we start to manage those variables so that we eliminate the number of bespoke panels that we have within that list below the standard units, we can start to say, well, this is a project that is suitable for COPE, and we take it to the next level. The next level, and it's not that far beyond, but you start to identify some clash detection on site with regards to sometimes the drawings are not always perfect. Eliminate those sort of clashes and make sure that you've got the best appraisal possible. And you start to optimize. So a little bit of, we call it nudging, so move that door 20 mil to the left or that wall 30 millimeters to the right. We can start to increase the level of standardization of those panel units on the project. So you get to appraise that whole project, whether you do it as the whole building or floor by floor, to improve the optimization if possible further. You also get to start to see that individualization of the units on site. So the graphical presentation of COPE will start to color code and identify. Every single panel will have its unique identifier. You can locate every single panel on the project, and you can very quickly visually tell which panels are which style of panels are which ones are bespoke, which ones are end of run, and by changing the variables within the product configurator, you can decide, yes, we're going to stick build the end of runs because it's much easier to take on board the tolerances, the as-built tolerances that we might face on site that we don't always foresee in terms of the planned drawings, and you can alter those tolerances within the product configurator, and you start to get sort of schematics and data which is going to tell you how many of each type of panel that you're needing on that project. So this is not just for the client to understand what they need, but it's also providing information as we start to build that portfolio of information required for both the assembly of the panels and the delivery and the installation. This is the point at which we generally sort of say that we need to sign off. Once we've gone through this, once we've optimized and agreed with the client that it's the best, we've gone as far as we can and they're happy with the level of standardization, off-site manufacture versus on-site install, draw a line under it, and we move forward to the next stage. And that's really where you're decided to proceed with the project. So the third pass is really, it's not necessarily a pass, it's just drawing out another level of information from the product configurator. So your schematics start to work with regard to panel type, floor level, and you can zone it off into areas if you want to label it into different areas of a building. So you can start to work forward with not just the overarching requirements for costing, for delivery purposes, but also the scheduling in terms of what types of phasing that you're going to get. The product configurator will actually break it down into component level, so we can start, so not just panel level, but also component level, so that we can start to bring those into bill of materials for the assembly process. So the offsite manufacturer process is directly linked to the design of the requirements and the scheduling of the requirements that are required for those projects on site. So you get a breakdown of all the materials that are required, and you can tweak those as required on the project. So we're removing error. So because we're using this digital pathway through design to the delivery of the project, we've removed some of the anomalies that will cause errors on the project, and hopefully maximize the efficiencies across just from the production and the assembly, also linking into the installation. So going beyond that, then we're manufacturing the panels off-site. So we're locally manufacturing the panels off-site. So you're manufacturing or assembling under controlled conditions. As I said earlier, the plasterboards are specifically designed to fit the 600mm wide unit, and they'll be manufactured to the height of the floor to ceiling span, because generally you'll have the volume and you'll have the lead time to be able to do that and to plan that ahead. You've got the quality control off-site as well. I don't know if you can see that on the image, but you've got a couple of little stations here and here for quality checks as the panels are being manufactured or assembled on the benches and put onto the pallets, ready to be loaded into the stillages for delivery and scheduling onto site. So you're bringing that quality control off-site. You're giving it a consistency across all of the panels that are being made. But when you look at this in terms of waste, and this is probably where some of the most significant savings are made, because you've had that foresight to plan ahead through the project. There's little or no waste. There's no offcuts of plasterboard. Even within the off-site manufacturing, if you're manufacturing the plasterboards to the right length and to the right height, apart from the bespoke units where you have to start splitting boards, you're reducing the waste, and you're keeping the waste off-site as well. So there are huge savings with regards to minimizing those waste streams and managing those waste streams on site. The panels themselves, in terms of the delivery, are put into stillages. So what we saw is them being loaded onto pallets, ready to be put into bespoke stillages. The stillages are collapsible and they're reusable. So you've got this sort of life cycle and full cycle of reuse on the delivery packaging. You might just need to put a hood over the top, depending on how exposed the panels are going to be before they're loaded into the building. Each stillage will take 10 panels. You can see on the picture on the left-hand side a mix of standard panels and also mixed panels on the lower stillage. And in the middle picture and the bottom of the screen, you can see how the stillages can be stacked, folded in and stacked, ready to be transported back and reused for the next schedule of deliveries. The panels are labeled with QR codes. The level of information that sits in behind the QR code can be decided with the client. You can either go to a level which identifies the panel into every single unique location on a project, but that sometimes gets a little bit challenging to manage. So very often the level of information is just identifying the panel type and the floor level or the zone that's going into, and then the drawings that the installer is working with. It goes hand in hand to provide the appropriate level of insulation to get the install correct. The deliveries can be sequenced with the build order loaded onto the floors as and when required. So as the building is built up in levels, the materials and the panels can be loaded in and delivered in to suit the build sequence of the project. So last slide, just to summarize what we've spoken about with regards to the InteWall system. So it's an alternative dry lining solution. So it's a pre-panelized dry lining solution as opposed to a stick built, but still delivers the same performance requirements that you're looking for to meet those regulation requirements or design requirements that you have on those projects across fire, sound, robustness, impact resistance in terms of the icons there. In terms of the efficiencies that can be saved. So projects that have been undertaken in the UK and Ireland have demonstrated up to 60% more efficiency in terms of their installation speed, the level of labour that's required as well with regards to essentially de-skilling some of the requirements. You still have to have the project supervised and oversight to make sure that the install is of the correct quality, but in terms of putting the panels together, that's obviously been done off-site and the quality control has already been introduced at that stage. Up to 90% waste savings. So that, as I said, that's really significant in terms of managing waste and the waste streams of plasterboard. If we look at traditional sort of stick build projects where plasterboards, framing, installations delivered on site and the boards are cut to suit the projects. Sometimes those projects you can see north of 20% waste on the plasterboard elements alone. So essentially, and there's a really good analogy that we speak about internally. You've got 5 trucks being delivered, and you've 1 truck potentially coming back with waste. So that's eliminating all of that waste that has to be managed on that project, or nearly all of that waste. And then in terms of the supposed to complement the actual design and the system is the digital pathway. So it's using that COPE software, that product configurator, to identify the appropriateness and manage the project from design through to delivery, and ultimately sign off on the project. All of the test evidence is fully substantiated, and you have that sort of golden thread of information running through as well to enhance the sign-off package, and all fully substantiated. And ultimately, as with all MMC, the ultimate game is to increase efficiency and reduce risk through the overall project. So thank you very much. That's to say a sort of a bit of a whistle-stop tour of the InteWall system. So quite happy to address any questions that have come in. Evan, I don't know if there's any primed there already. So
we'll take it as a compliment, Jason. There seems to be only one question, so we'll assume you covered everything off. But that question comes from Andre. I hope I'm pronouncing that correctly, from CNW O'Brien Architects. And the question is, how do you run systems into it? So I assume it's other partition systems abutting it, if I'm reading that correctly.
Yeah, so generally you'll have and I probably didn't stress enough in terms of the InteWall is very much your party wall, and you'll have internal, as you're correct in saying, you'll have internal walls running into the system as well. You can treat those as bespoke, so you can put in horizontal flat straps to receive the fixings of those panels. You can design in the sort of the design stages. You can look to ensure that your junctions of your 2 partition, or your junction of your panels, are meeting at the location where interlocking adjoining internal partitions are running up to that party wall. So again, you then have the grounds of the metal framing to fix into. So it's no more than you would have with your standard traditional dry lining, making sure that you have the appropriate grounds in the right place to run those other sort of systems. And the reason that we're targeting party wall or separating wall as the appropriate solution for InteWall, there's nothing to stop us moving forward in the future and actually providing systems which are single stud boarded on both sides. But then you move into, well, where are the services, and you get that you're introducing a much higher level of variables into the project. If we look at the requirements for separating walls and party walls, you're not allowed to run services in the cavity of those systems. So you're eliminating where you're putting the sockets and the switches on those walls, and you need to put those into supplementary service cavities as well. So it can very much be integrated with your traditional dry lining solutions for the internal walls of the project. But again, one of the reasons that we've highlighted we're targeting InteWall for the party walls is when you look at, certainly when you look at the residential builds, and you look at the sort of percentage of wall that is party wall and the percentage wall that's internal wall, especially with open plan living in apartments, then you're certainly in the sort of 60-70% of your area, your wall area can be InteWall, and then you're optimizing 80% of that InteWall in terms of standardization on site.
Very good. So I suppose, Jason, in short, it's no different to what we would recommend in our standard stick built partitions in terms of forming abutments, just ensuring that you've got the correct level of grounds when you're forming the connection. So just a few more questions here, Jason. So Declan Duran, an old friend of ours, is asking, how do we cope with the deflection head? And you're probably going to have to go back up to your slides, Jason, to demonstrate this.
I'll flick right back to the very start through the slides. It was sort of highlighted in the first image there. So essentially, Declan, you're building your panels, or the panels that are supplied to site are not quite fully spanning from floor to soffit. They stop 50 millimeters short. So what you see in the diagram on the right hand side are cloaking sections. Those cloaking sections, either glass rock in terms of sort of the specialized plasterboard, or metal angles for your 90-minute solutions, are used to trap the partition in place. In that void, and it's not shown in this diagram, but in the void but above the top of the panel and the underside of the soffit, you have a mineral wool insulation acting as your fire stopping and also accommodating. So it's a flexible mineral wool so that you can accommodate deflection in that location. Also, what's not shown in that sort of schematic, just to sort of simplify things, is there is a central angle which you're actually pushing the two partitions up to act as a sort of stop and brace internally inside. But essentially, it's, your deflection head is managed by the fact that the panels are supplied slightly shorter than the floor to ceiling span, and cloaking angles are used to trap the partition and give it its stability at the head.
So it's important to point out that there's no connection between the retaining angles and the panel itself. Therefore, any deflection is accommodated within the build-up.
Yeah.
Excellent. So one last question here from Martin, and he's asking, would these systems work within timber frame structures?
They would. I suppose the actual system itself will work within any structure, because essentially as long as you've got a suitable structure to mount your floor guides, your wall guides, and to fix your cloaking angles at the head. So obviously you need to marry the structural supports in the right areas. The separation is provided by the system is the separation that's tested. It possibly, in terms of the project as a whole, you might find that and I don't know, you might have a project that is very, very much suitable for this, but in terms of the volume and the optimization that can be achieved in those types of projects, it might be a little bit more challenging, but not to rule it out moving forward.
Yeah, I think it's also important to point out that we've already had some opening discussions with some of our peers in the 3D modular world as well, where they might see opportunities, So again, it's primarily aimed at, as Jason said, at certain types of building structure where there's a lot of replication, such as apartments, hotels, possibly healthcare. But again, there's other opportunities for sure. I think that's us covered off with questions, unless anybody else has anything to ask or add.
I'll just make a point on that, Evan, if you don't mind. I think what stood out to me there was the speed and the waste. I think it'd be a pleasure to walk through a site with no black partition screws all over the floors, getting stuck in your boots. So I look forward to walking onto one of those sites, Jason, with over 80% standard InteWall panels around. But I really enjoyed the presentation, Jason. We appreciate yourself and Evan coming on and demonstrating that. If there's no more questions from anyone online, we'll wrap it up here, and thank you all for your time. And we try to keep these between 30 minutes and 45 minutes, and I think we've managed that today. So without any further questions, we'll wrap it up there, and we will publicize next month's. Actually, we won't be doing one at Christmas. The next one will be in January, and we will publicize that when we come back after the holidays. So
thanks, Paul.
Thanks, guys.
Thanks very much.
Thanks, everyone.
Cheers.
Thanks, all.